In this unit, we're going to look at the graphs of our trig functions, specifically just sine and cosine. But in this learning objective, we're going to look at all 6 just to learn the basics. So it's important to look at graphs of functions because they are functions and we can plug in any value. We just focused on very specific angles in our last unit, pretty much anything in like a pi over 6 or a pi over 4 or something like that. However, they are functions, so we can plug in any value you want and create a graph. Before we get to the graphs, there's one really important fact about sine and cosine, and that's what they're called periodic. This simply means they repeat over and over again. So if we think about our sine function, we have a unit circle, and our sine values are the y values. So as I go around the circle, all these y values for an angle are going to give me my sine. And when I get back around the circle, I just start repeating the same ones again. And how long does that take? It takes me 1 revolution of the circle, and that's 2 pi. So every single 2 pi, my sine graph is going to repeat itself. All right, so let's look at the graph of sine of x. So when I graph a trig function, all right, I'm just actually going to graph, it'll look something like this. And if I can graph it from 0 to 2 pi, then it just repeats. So I can basically just copy and paste this segment of my sine graph over and over again. All right. To help me graph it, I'm going to break it up into the quadrants. So 2 pi, if I break it up into the 4 equal quadrants, the first quadrant ends at pi over 2, the second at pi, and the third at 3 pi over 2. This might not be something that you noticed as you're doing the previous units with sine and cosine, but if sine is a y value on the unit circle, the biggest it can be is at the top of that circle, and that is 1. The smallest it can be is at the bottom of that circle, and that is -1. All right, so I'm going to get some points on my graph. When I put in 0 into sine, all right, using my unit circle, sine of 0 is 0. And we learned about this when we were learning about functions. If you put in the value that's your x value, the thing you get out is your y value. So that gives me the point 0, 0 for my graph. Sine of pi over 2, when I put in pi over 2 into sine, I get 1. That means the point pi over 2, 1 is on my graph. And I'm not going to write out the other ones, just say them. Sine of pi, when I do pi, sine is 0. When I do 3 pi over 2, sine is -1. And 2 pi, sine is 0 again. All right, so these are the 5 points I get from my quadrants. And you kind of just look at the circle as you rotate around. As you rotate around the first quadrant, your sine values, your y values are going to get bigger until you get to that pink peak. Then as you go down to pi, the y values are going to get smaller. Going down to 3 pi over 2, they keep going down and getting negative. And then they come back up to 0. Right, so this is the sine graph. This is not the full sine graph. But again, it just repeats. So after this, it's just going to do this again. And then it'll do it again and again and again. Going to the left, again, it'll just do the same thing. All right, so this is called the sine wave because it's just like this infinite wave. But if I just have this kind of part here between 0 and 2 pi, I just copy and paste it over and over again to get my full sine wave. All right, cosine is going to be similar. I'm going to start off with the same thing. I can graph it from 0 to 2 pi, I'm good. Break it up into the quadrants. All right, just like sine, the biggest cosine can be is the right side of the circle is at 1. The smallest it can be is at -1. And now I'm going to get some points. When I put in 0 into cosine, I get 1. So that tells me the point 0, 1 is on cosine. When I put in pi over 2, I get 0, which tells me the point pi over 2, 0 is on the cosine graph. Again, just going around the unit circle, pi is going to be -1 for cosine. 3 pi over 2 is 0. 2 pi is 1. And it kind of looks like it's a V, but just like the sine one, it's going to end up being a wave. So it's going to kind of curl down through these points. So that's the cosine graph. Again, that's not the full graph because it's going to just keep repeating. So after this, it's going to curl back down, and come back up, going to the left, same thing. All right, so this is my cosine wave. All right, you can see they look really similar. All right, sine would look like this. Let's put it in yellow. All right, that's my sine, oops, messed it up a little bit. That's my sine graph, and it would keep going forever after that. And so how do I tell them apart? I just look, when I want to tell them apart, I just look right here. All right, cosine of 0 is 1, so this one that starts up here has to be cosine. Sine of 0 is 0, so it's the one that has to be there. That's sine. So really, they're both just these waves, but just kind of knowing which one starts where tells you the difference. That's just the most important thing in this video, knowing the difference between your sine and cosine waves. Next, we're going to look at the other ones. We're going to look at them a little quicker because we just need to basically know what the answer is. Cosecant. We learned about this in the bonus objectives from the previous unit, but cosecant is just the opposite of sine. So this is the sine graph, and you can see because it starts at 0, 0. This is the sine wave that's given on this chart. And then for everything, I'm just going to do 1 divided by that number. So like when sine is 1 up here, 1 divided by 1 is 1. So cosecant is also going to be 1. So at the peaks, cosecant is also going to be 1. All right, the valleys, it's -1 divided by -1 is -1. So they meet there and there. What happens if I try to plug in 0 into cosecant? Cosecant of 0 is 1 over sine of 0, which is 1 over 0. And that's bad. You can't divide by 0. So this is undefined. And we learned about this in our rationals unit. If you try to divide by 0, it gives you what's called a vertical asymptote. So you have to put these dashed lines here. Whenever sine is 0, you're going to get a dashed line. That's a vertical asymptote. And in between those, you're just going to get these kind of curves that look like they touch the outside of the asymptotes. They go the opposite direction. All right, so this is what the cosecant graph is going to look like. Not the red graph. The red graph is sine, but it's related to sine. So it's kind of these kind of parabola-looking shapes that go the opposite direction of sine. Secant's going to look similar because secant is 1 over cosine. So this is the cosine graph. So just like the sine graph, they're going to be the same at the peaks. And then whenever cosine is 0, you're going to get an asymptote. So you get something that looks like this. Just all these kind of parabola-looking things repeated over and over again. So that's the secant graph. All right, tangent. Talk on the bonus objectives from last unit. Tangent is sine divided by cosine. So just like we just saw, whenever the bottom of a fraction is 0, you're going to get an asymptote. So I put the cosine graph on this graph already because whenever that is 0, you're going to get an asymptote. And then if we look at, say, this point, when I put in tangent of 0, that's sine of 0 over cosine of 0 is 0 over 1 is 0. So at 0, tangent is going to be 0. It's going to happen the same thing at pi and 2 pi and so on. All right, and you can plug in a bunch of points, but I'm just going to kind of tell you what the graph looks like. The graph just looks like this. Between each of these asymptotes, you get this kind of curve that kind of looks like x cubed. If you graph x cubed, it looks kind of similar. All right, just that in every single graph. And then cotangent's related to tangent. Cotangent is cosine over sine. And dividing by 0 is bad. So whenever sine is 0, you're going to get an asymptote. And then cotangent looks similar to tangent. In the middle, you're still going to get these zeros. But the reason it's different from tangent is because they go down instead of up. Right? Obviously, I can't draw it like a computer, but they're the same thing just over and over again. So now on the last slide, these are the computer-generated pictures for all of them. And this is basically what your skill check's going to be. It's going to be identifying which of these is which. So here's how I do it. First thing I know, the waves. So I have a wave here and a wave here. Those are going to be sine and cosine. And how do you know which one's which? I know cosine of 0 equals 1, and sine of 0 equals 0. So I plug in 0 into cosine, I should get 1. So that tells me this one is cosine. And I put in 0 into sine, I get 0, so this one is sine. Alright, so that helps me with the first two, knowing that sine and cosine are waves, and figuring out what happens at 0 differentiates them. The next ones I look at are the ones that look like a bunch of parabolas. Because I know those are secant and cosecant, and then which one's which. When, let's see, so secant, let me write it up here. Secant is 1 over cosine, and cosecant is 1 over sine. As we saw when we did the graphs, these things are related to our sine and cosine waves. Looks like this. Kind of hits the peaks and valleys. Right. And the green line that I drew in this top middle one looks just like that top left graph. It starts at 1. So this one is related to cosine, which tells me this one is secant. This one in the bottom left, the curvy line, the wave I drew that's connecting kind of the parabolas, looks like sine, so that tells me this one is cosecant. Alright, so the ones that are a bunch of parabolas look like are secant or cosecant, and you just figure out which one is which. And then the only remaining ones, those are similar. The ones that are going up each time is tangent. The one that's going down is cotangent. Alright, so that's exactly how I do it. Identify the waves, one sine, one's cosine. Identify the parabolas, one's secant, one's cosecant. Tangent goes up, cotangent goes down. That's helped you get to the last two. Alright, so like I said, you're going to do a skill check. Your skill check is literally the last slide. When I gave you the 6 graphs, label them all correctly.